water is 4 inches.
Mhm.
I don't know that I believe that, but that's what it says. It seems like not enough, or it seems like that's way too deep for it to sink in and rise out again. But what do I know? Now the other one, they're saying you've got to go and graph the other one. Like they're saying, we're not going to give you the data points. We're giving you a function. All right. So is it clear what the difference is or what's going on? Or not?
I don't know.
You're not sure? I mean, it's like, is the scenario clear, I guess? So this is Anne's, this is Anne, and she, hers went under the water and then popped out 1 second later.
Mm.
And the distance below is, this is 4 inches down.
All right.
Kind of makes sense.
Yeah, it does.
Okay.
Made sense.
Now Reese, on the other hand, they're given a graph or function that we should graph. Okay. Do you remember how to graph something like this or what you might do to graph it?
No, I don't.
Not really. Yeah. So this is what's, I think, the challenging here is you've got to know a few things to be able to even attempt a problem like this. So let's do it by hand, and then we'll go to the graphing tool and do this. So let's set this function equal to 0. 7t squared minus 7t equal to 0. Is there a greatest common factor between those two terms?
I don't know.
Is there a number that goes into both?
Oh, 7.
7, yes. Very good. And then between the exponents, t squared and t to the first, which is the smaller of the two?
7t.
So t to the power of 1. Okay. So we've got to figure out what goes in parentheses here. Now it's a little crowded down here at the bottom. So let me just back this off a little bit. It's not gonna let me do that. Okay. Let me just rewrite this here, freeing up some space. Okay. So 7t comes out. We've got to figure out what goes inside parentheses. Now, to do this, you're dividing each of these by 7t. Okay, and I'll take either one of these. Can you tell me what 7t squared over 7t is, or 7t over 7t? Can you tell me what that is? Either one.
7t over what?
This division. I'm asking, can you divide either of these for me? I'll take either one if you know the answer.
So it's in 1.
So I say that one more time.
1.
The one on the right is 1. This one on the left, if we break it up, it's 7t times t over 7 times t. Anything that's the same in the top and bottom cancels. So what is left over?
1t.
Just a t, yeah. Okay. Very good. All right. So that's good. So we know that the second rock, believe it or not, this tells us that the second rock pops out of the water at t equals 1 second. Because there's 2 0 points. We know that it went into the water at 0 seconds, just like the other person, but it popped out at, you can think of that as the dive in, and that's the dive out, or the rise out, I guess. Doesn't dive out, it rises out. Okay, and I totally understand if this is unclear, because this is a weird question. It's not kind of a standard question that you might see. So a couple more things here just to talk about here. If we're looking at a quadratic, actually let me draw it differently. If we're looking at a quadratic, do you remember what this point is called right here?
That's the vertex.
It's the vertex, yeah. And in this case, it's the min for this one. Now, if a quadratic is in standard form, and the original function is in standard form. This is considered standard form because it's in descending order. Notice the exponents go down. I know it's t instead of x, but they go down. T squared, t to the power of 1. Can you tell me the value of a, the coefficient in front of the variable here, in front of t squared?
That's up to the power of 2.
Just the coefficient, just the number out in front.
Oh, 1.
Nope. What number is out in
Oh,
front here?
7.
7. And then b is the number in front of x, which in our problem is the number in front of t, and it takes on the sign. What would that be?
That's just -7.
-7. Good. And then the c value, there's nothing here, so c is actually equal to 0. All right. Now, when a quadratic is in standard form, the vertex is at minus b over 2a, minus b over 2a. Okay. What is the value of b again?
It's that's y. I mean, it's -7.
So negative of -7. And then a is positive 7. So this is 7 over 14, which is 1/2. Okay. So this is telling us where the min occurs. The min occurs at 1/2. All right. Now, to find the y value, of the vertex, you have to take that value and put it back in to the original function. So we're going to put 1/2 in for t. 1/2 squared minus 7 times 1/2. I can't remember. You allowed to use a calculator in this class?
Sometimes, most of the
Sometimes.
time.
Okay. Okay. So if you have a calculator handy, I'd like you to try to calculate this. If you don't, we'll do it by hand.
Negative 1.75.
Yes. Very good. Okay. All right. Now this is going to make more sense when we go and graph it. So I'm going to do that now for us. I'm going to go new share. And this is what this along with what we've been doing, you'll want to get down in the notes, but let's first look at, when you're seeing my screen. Yeah. So we're going to first go, I'm going to graph the data points from Ann. So the data points were at 0, 0, 0.25, -2, and 0.5, -4. So this is what you'll want to get down on your graph there at the bottom. And then you can see it comes back up right there. So I'm going to change my window a little bit here. I don't really like that it's, well, I guess that maybe this is what you want to see, because your window is, I don't know why your teacher gave you so much room to graph that, but you want to show this one on the graph on the left, I guess. And if you can envision a quadratic going through those, that would be Be great.
Mm-hmm.
Did you get those down?
Yeah.
Great. Okay. Now let me just see if I can fit a curve to this real quick without doing too much effort. And let's restrict this from 0 less than equal to x less than or equal to 1. Okay. Let's see if I can scale this 2, 10, it's 20, it's too much, 18, 15, 16. How did your teacher come up with this one? Anyway, let's use 16. That kind of matches it. Just go with that for the moment. Now for the other one, for Reese's is a little bit different. So y equals, actually I need to grab this window or it's going to mess up our graph. So y equals 7x squared minus 7x. Okay. So hopefully it's not too small to see here, but what you should see is that both the rocks go into the water and pop out, go into the water and pop out. Do you see that?
Yeah.
All right. Now, the depth is the y value, the vertex. So which has the lower y value?
Lower by value, it's the blue.
The blue. Yeah. So what you want to get down in your paper there on the left is the two graphs. You want to have the blue one. The blue one is the one on the left. That's Anne. And then the green one's going to be the one on the right, Reese.
Uh-huh.
So I know I've got them overlapped, but you want to show them separately on your paper there.
All right, cut it down.
Okay, so let me snip this in. We'll talk about the last question. Let me know when you got that down on your graph.
I got it down.
Great. So there's two questions we need to answer. Whose stone went further underwater? And we can answer that now. That's the blue one. Okay. That's Anne. Okay. And then how do we know? We know that it's the vertex is lower on the graph. So it might be good to label the vertex. This one was at 1/2 comma -4. This one was at 1/2 comma -1.75.
Mm-hmm.
Okay, and then the other question we can answer now, which stone stayed underwater longer? Really what you should ask yourself or answer is which one, or when do they come out of the water? When do they pop out of the water?
When it pop out of the water,
Yes,
like at 1 second.
at 1 second. So they both at 1 second. So there is no one being in longer than the other. They're both underwater the same amount of time.
So wait, so they're both at 1 second. So
if you and a friend hold your breath underwater for the same amount of time, who stayed underwater longer?
No one.
That's right. So both are the same. So you could say neither or neither. They're both in the same.
Mhm. All right, write it down.
That is it for this problem. So I'd like to do a little bit more same sign, opposite sign problems with you. Unless you have something else you would like us to work on.
No, I don't have anything else.
So you mentioned yesterday, using money. So even if I put an X in a problem like this, I still want you to think of it in terms of money. Minus 2x plus 4x. Think of it as you have $4 and then you owe someone $2. What is the net result of that?
What?
You mentioned yesterday money was really the easier way to think about these problems. So ignore the X. Like the X is just part of the answer. You've got positive 4 and negative 2. Think of it like you have $4, but you have to give away 2 or you owe someone 2. What is the result of that?
I'm sorry, you're breaking up. Just like one more time.
I'm just asking for the result of this. What is the result
The
of
result.
this? Yes.
They both ended up at the same time. They got up at the same time.
All right. So hey, if I'm not sharing the screen, you gotta let me know. I didn't realize
No,
that.
no,
I
you are. It's
well
just
no
you're
no
breaking up
no
a bit.
I was we've worked through a bunch of other stuff besides that. I didn't realize we weren't showing this. So okay, so what I was trying to get you to see, I guess we'll go through this again, is the one who's got the lower vertex is the one that went underwater further. Let's just backtrack. Did you get something like this down? Anne is the one who's went further underwater.
Mhm.
Great. And it's because the vertex is lower on the graph. Literally that graph goes down further than this one. And then we tried to answer this one by saying, comparing it to, you and your friend swimming underwater. Well, neither of you were longer because you both were underwater for the same amount of time. All right. So now I just moved on to a new question. That's why you didn't know what I was talking about, because you couldn't see it here. I'm asking you to give me the answer. Give me the answer to this one. One's negative, one's positive, but think of it in terms of money. Positive 4 minus 2. You have $4, you owe someone $2.
Then you owe them $4, or you have $4. I mean $3. 2.
2x. 2x.
2.
So the answers are going to have the variables with them today because I want us to get more comfortable with this. Okay, so here, again, another situation. You have $3 and you owe someone $6. What's the result of that?
3x to the power of 2.
You still owe them money though. If you owe someone $6 and
Oh,
you hand them
negative 3x.
negative 3x squared. So if they're both x squareds, the answer has an x squared in it. Okay, let's try another couple here. 5x minus 7x.
Oh, negative 2x.
Yes, very good. How about this one?
That's negative 2x.
So they're both negative, right? So that means you owe someone
so
$3 and then you owe them 5 more.
So 2x.
And you owe your dad or you owe a friend $3 and then you also owe them $5 from something else. How much do you owe them?
$2.
No, you still owe
Well,
them.
$3. Oh, you give them $3.
No, that's not what we said. You owe them. The negative means you owe.
Oh, so it's
And then you owe them from something else in the past. They remind you, oh yeah, you still owe me the $5 from before.
so negative 8.
Yes. Yes. How about this one? 9x minus 7x.
No, negative 2x.
Tell me the scenario. What is the
It's
scenario?
2x.
Well, give me the
2x.
scenario. What is the scenario you're thinking of either way?
All right, so you have $9. You can give someone $7.
That's right. And what's the net result of that?
Negative 2 or 2x.
Which one is it?
Negative.
Okay, so your scenario is great. Like you have $9, you give someone 7, you still have money left over, and we consider that positive. All right, so let's try another one here. Let's go 4x squared minus 5x squared.
So you have 1x squared, negative 1x squared.
Okay, so which one is it? Give me your scenario.
It's negative 1x squared, and you have $5, and you give someone $4.
So the positive's like what you have. The negative 5 is what you owe.
Oh, so it's just 1x squared.
Well, no, your answer is right, but your scenario was different. You described it as I have $5 and I give someone 4. That means you have $1, which we would think would be positive. I really recommend thinking of negatives as owing or purchasing, and pluses is what you have. All right.
All right.
So the good news is we are all done for today. So we're going to stop.